So we're looking today at the point slope formula, or the point slope equation, and this is one of my favorite things to teach. I think this is really, really cool. It allows us to do some really neat things and solve some problems that may have been complex for us in the past. It all begins with the definition of slope. Now, I'm not going to go through and talk a whole lot about the definition of slope today, because if you're viewing this video, chances are you've already done quite a bit of work with the slope formula. Suffice it to say that the slope of a line is the relationship that exists between the rise and the run of the line, or the relationship between how much y changes and how much x changes. So if you're looking at the graph of a line, it would be comparing how fast I'm going up with how fast I'm going over. If all of that is not already comfortable for you, then chances are you need to go back and watch a video on slope prior to viewing this particular video. For today, what I'm going to do is I'm going to do some really cool things with this formula to rearrange it just a little bit to put it into a more useful form. The first thing I'm going to do is I'm going to put some parentheses around the numerator and around the denominator. I do that for a very specific reason. First of all, the long division bar in math actually acts like a set of parentheses anyways. It is a grouping symbol because it says do the things that are on top first and do the things that are on bottom second. Do both of those things before actually performing your division. Well, that's the same thing that parentheses would do, is they'd say do this first, do this second, divide last. So it really doesn't make any significant changes. However, it is going to make what I do next less confusing. I'm going to use the property of equality. The property of equality says I can do whatever I want in an equation without changing the truth of the equation as long as I do it on both sides. I can do whatever I want as long as I do it on both sides. Or whatever I do to one side of an equation, I have to do to the other. That is not the focus of this lesson. If you're unsure on the property of equality, go back and watch a video on that. For now, suffice it to say that the property of equality allows me to multiply both of these sides by a number. The number that I choose to multiply by is x2 minus x1. Now, some of you are saying, well, that's not a number. It actually is a number. I just don't know what the number is. If I knew what x1 was and I knew what x2 was, then I could subtract those and come up with a number. Regardless of what number that is, that's the number I want to multiply by. And if I do it on one side, I have to do it on the other as well. I chose that because if I'm multiplying two fractions together, I can simplify, cross-simplify things that are alike to create ones. Here again, that's not the primary focus of this lesson, so I'm going to assume for a moment that that makes sense to you. If those become ones, what's left is x2 minus x1 multiplied by m equals 1, 1, 1, y2 minus y1 over here all by itself. There again, that's the property of equality that allows me to make that change. Second thing I'm going to do is a formula or a rule that's not written here. It's called the property of symmetry, or the symmetric property. The symmetric property says if two things are equal to each other, it doesn't matter what side of the equal sign they're on. For example, if I have 1/2 equals 0.5, I could write that as 0.5 equals 1/2, and it's still equally true. I'm going to do that here. I'm going to move my y2 minus y1 to the left side, and I'm going to put my x2 minus x1 times m and put it on the right side. There again, I'm just switching which side of the equal sign it's on, and it doesn't change the truth of the equation. I'm going to use the commutative property. Commutative property that says when you're doing multiplication, it doesn't matter which thing comes first. 5 times 2 and 2 times 5 are the same thing. And I'm going to put this m in front of that formula. y2 minus y1 equals m times x2 minus x1. And we're almost done. I'm going to go one step farther. See how I have x2 and x1? When we did our slope formula way back at the beginning of this unit, we said we call this x2 and x1 because when we calculate the slope, we're given two examples of x's and y's. This one being x1, y1, this one being x2, y2. And we are going to arrange those examples into our formula. But for the sake of today, let's say we don't actually know those values. We don't actually have examples of x and y. What I'm going to do is I'm going to say instead of having a known y2 and x2, I'm going to switch that back to being an unknown. And I'm going to make this y minus y1 equals m times x minus x1. Here again, all I've done is said, instead of having a known value for y and x, I'm going to switch to an unknown value of y and x. That creates for you what we call the point-slope equation. Take just a moment and sit in awe of its majesty. That's a joke. A lot of you are probably thinking, okay, so you did a little bit of algebra and rearranged it. Why would you bother to do that? Well, in this form, rather than taking an example of x and y and another example of x and y and calculating the slope, I can use this form to create the equation of a line anytime I have a given point and a known slope. So, for example, if I'm asked to give the equation of a line that passes through the point negative 2, 3 with a slope of negative 3/4, I can just take that formula and plug these values in. Remember, this is the only example of x and y I have. So I would say y minus, the only example of y I have is 3, equals my slope, which is negative 3/4, x minus, the only example of x I have is negative 2. I use my distributive property and say y minus 3 equals negative 3/4 x. This is a plus 2. Negative 3/4 times 2 is negative 6/4 or negative 3/2. Using the property of equality, I'm going to add 3 to both sides and come up with the equation y equals negative 3/4 x plus, this is 3, this is negative 1.5 plus 1.5. Notice that I now have an equation in slope-intercept form that has a slope of negative 3/4, and if I were to plug in a negative 2, negative 3/4 times negative 2 is positive 1.5. 1.5 plus 1.5 would give me 3. It meets both conditions. I like this formula because once I have it memorized, all I have to do is plug in numbers and I get the correct equation every single time. Notice I did follow good math practice in that I rewrote the original problem, I substituted the values in that I know, and then I simplify it to the form I'm looking for. Now, below here I have 2 more examples of that same process. I would encourage you to pause the video, try the first one on your own, and then watch the video to see if you did it correctly. If you do it correctly, then go on and try example 2 the same way. If you did it incorrectly, go back and make corrections on how you did the problem. You'll notice that I'm just going to keep going. I always rewrite the formula. It says, give the equation of the line that passes through the point 2, 5, that's x1, y1, with a slope of 4. That's my slope. Y minus y1 is 5 equals m, that's 4. X minus x1 is 2. I use the distributive property to pass out the 4. That's 4x minus 8. And then I use the property of equality to get the 5 to the other side. y equals 4x minus 3 is the slope-intercept equation that gives me a slope of 4, and that when I plug in a 2 will also give me a 5. 4 times 2 minus 3 is 5. The last example of this says I have a point that passes through negative 3, 1 and has a slope of negative 2. Using good practice, I always rewrite the formula, plug in the known values, and then simplify. Y minus 1 equals minus negative 3 is a plus, negative 2x minus 6. Property of equality moves the 1, and there's your solution. Not too bad, right? This next example is slightly different. Notice it says, give the equation of a line that passes through these 2 points. But my formula, my point-slope formula says, I need to have a point and a slope. That's why it's called the point-slope formula. I don't know the slope. However, I do know how to find the slope because all of this began with the slope formula. So what you're going to want to do is use your 2 examples and calculate the slope. 3 minus 2, 4 minus 2 gives you a slope of 1/2. Once you know the slope, you can take your slope and either one of these points, plug them into your point-slope formula, and it will give you the equation of the line. I'm going to pick, to start with, the point 2, 2. This is y minus, y1 is 2, equals m, my slope is 1/2, x minus x1 is 2. Just like the previous examples, I'm going to use my distributive property, followed by the property of equality. There's my equation. Now, just for the sake of illustration, I'm also going to do this using the slope of 1/2 and using the other point, 4, 3. Y minus 3 equals 1/2 x minus 4. Y minus 3 is 1/2 x minus 2. Y equals 1/2 x plus 1. Notice it doesn't matter which of the 2 points you use, you're going to get the same equation. So my rule of thumb is just pick whichever point looks easiest to you. Now, I know some of you are already thinking, Mr. Nunley, you did not rewrite the original problem. The reason I did not rewrite the original problem was I had it rewritten right here. If it's written on your sheet of paper for you, it doesn't make sense for you to have to rewrite it again. Now, I'm going to put up 2 examples here on the screen. I would recommend that you take a second, try one of those on your own, then watch the video to see if you're doing it correctly, then do the same thing on the second. Of course, I am just going to keep going. Y minus y1, or I should say y2 minus y1 over x2 minus x1 is how I get my slope. It doesn't matter which of these is 1 and 2. I usually just label them in order. This is 4 minus negative 4 equals negative 1 minus 3, giving me 8 over negative 4, which is negative 2. Y minus y1 equals mx minus x1. I'm going to pick this one to work with. Y minus negative 4 equals negative 2 of x minus 3. That's y plus 4 equals negative 2x plus 6. Subtract 4 from each side. Y equals negative 2x plus 2. Over here, your slope, y2 minus y1 over x2 minus x1. Let's call this x1, y1, x2, y2. This is 5 minus negative 1 over 8 minus 0. Oh, this one's going to be fun. This is 6 over 8, which is 3/4. I'm going to pick the 8-5 because I really don't want to have to deal with a negative number, although we may find that having a 0 might have made it worthwhile. Y minus y1 equals mx minus x1. Y minus 5 equals 3/4 of x minus 8. Y minus 5 equals 3/4 x minus 6. Add 5 to both sides. Y equals 3/4 x minus 1. Is that what you got? Hopefully it is, and hopefully you find that to be helpful. Best of luck.